Hello, welcome to a quick video about diffraction and polarisation. Diffraction is the bending or spreading of waves as they pass through an aperture or past a sharp edge. The plane of polarisation of an electromagnetic wave is the plane defined by the direction of travel of the oscillating electric field. In Stage 1 physics, you need to be able to explain a range of light-related phenomena, including diffraction and polarisation, using the wave model. So, as I just mentioned, diffraction is the bending or spread of light waves as they pass through an aperture or as they passed around the corner. The magnitude of diffraction is dependent on the size of the aperture relative to the wavelength of the wave, and maximum diffraction occurs when the aperture gap is equal to the wavelength. So we've got some wavefronts that are travelling through an aperture in our pictures below, and the aperture is different in size in all of these three images. So in the bottom one, the diffraction is most significant because the aperture is smallest, it's the most similar to the size of the wavelength. In the second image, the aperture is a little bit bigger. You can see diffraction occurring on the edges, but the wave is still a little bit flat in the middle after it passes through the aperture. And then in the third picture, there's a little bit of diffraction again on the sides of the wave fronts, but a lot of that wave is not impacted at all by diffraction because it's still travelling through straight as it was before reaching the aperture. And we've just got a little gif of this process happening, so some flat straight wavefronts approaching an aperture, and then those waves diffracting as they come through the aperture and spreading out. So now we'll have a look at polarisation, and polarisation is the confining of oscillations of a wave to a single plane relative to the wave's direction of motion, and this is how Polaroid sunglasses work. A Polaroid is a polarising filter that permits transmission of plane polarised electromagnetic waves, and they consist of strands of molecules that are oriented perpendicular to the plane of polarisation, and they absorb any electromagnetic waves with an electric field orientation that is not the same as the plane of polarisation. And I'll just point out that the plane of polarisation refers to the electric field plane. A wave's oscillating magnetic field will still pass through even if it's perpendicular to the plane of polarisation. So we're just looking at the electric field here. So in our diagram, all of these waves that are represented here are the electric field. The magnetic field just isn't shown. The only wave that can get through this Polaroid here is a wave that is exactly perpendicular to the parallel strands of molecules that are arranged in this Polaroid. All the other waves are absorbed by the Polaroid and the molecules in the Polaroid. So an electromagnetic wave with an electric field that has a plane of polarisation that is perpendicular to those strands of molecules can propagate through, and because it's been able to propagate through, its magnetic field will also be able to propagate through. So the strands of molecules interact with the electric field, and if they're able to stop that electric field, then the whole light wave, which consists of an electric field and a magnetic field, is absorbed. If the electric field is able to travel through, or the oscillating electric field is able to travel through, then the magnetic field will come along with it. Up the top, the image is looking at some Polaroids. So if you've got Polaroids with axes or a plane of polarisation that are parallel to each other, or they're aligned so that those axes are parallel, then you'll be able to see through those Polaroids. However, if you then rotate one of those Polaroids so that the axes or the planes of polarization are perpendicular to each other, then you won't be able to see through the overlapping part of the Polaroid because you're blocking both planes of light. So no light waves will be able to travel through because the horizontal and vertical planes have been blocked. And that's what we see here in this photo of a pair of sunnies that are overlapping another pair of Polaroid sunnies.